Let's talk about trig proofs, okay? These can look very overwhelming, but they're not that bad if you learn the identities and you learn the methodologies. Before we get started, I want to make it clear that I am making the assumption that all of the people watching this video, their teachers have provided them something that looks like this, a trig function identity sheet. Okay, 99% of the students I've come across, their teachers have provided them something that looks like this. The alternative would be that you would have to memorize all these, which if that's the case for you in your class, my heart goes out to you. But for the majority of us, our teachers have provided something that looks like this. So if your teacher hasn't, I would suggest one of two things is happening. Either one, you're not paying attention, you actually did receive this, or two, your teacher is just mean, in my opinion. In any case, let's proceed with the proof. So this equation, or this question rather, is asking to prove the left side to the right side. The left side, 1 plus sine theta over 1 minus sine theta. The right side, 2 secant squared theta plus 2 secant theta tan theta minus 1. So, tip number 1 for all trig proofs. Get everything in terms of sine and cosine. I am a big fan of this strategy, and it's just worked well for me. It's definitely not required, but it would be my number one tip for students tackling these problems. You can see the left side is already in sine format, so we won't touch that for now. We'll put a pin in that, which is totally fine. So let's work on the right side. 2 secant squared theta. We know that secant squared theta is the same as 1 over cosine squared theta. So we can just rewrite this entire thing as 2 cosine squared theta. Okay, plus 2 secant theta tan theta. Well, we have 3 parts there, so let's write each one. 2 secant, we said, is 1 over cos theta, right? And tan is sine theta over cos theta, all right? And then the minus 1 we don't touch, okay? The next step, let's consolidate this middle term. So we have 2 over cos squared theta plus 2 sine theta over cosine squared theta minus 1. Okay, now something interesting is happening here. And what is that? Well, term 1 and term 2 have the same denominator. So we know in the next step that we're going to be collecting like terms and we're going to be adding those together because we can. They have the same denominator. So let's see that in advance and make sure that this minus 1 is invited to the party. Make sure that they have a common denominator as well. So how do we do that? Well, we'll throw it over 1, which is just itself, and we'll multiply it by cos squared theta over cos squared theta. Okay, why are we doing that? Well, again, we want to make sure that its denominator is the same as the other two, so we can work all together. And when we put cosine squared theta over cosine squared theta, that's just equal to 1. So it's you're just multiplying it by a fancy 1. And it's not going to change anything in relation to the side. It's just going to make it easier to work with. So let's continue on. I'll show you what I mean. So now we know that all of these terms have the same denominator. So it's going to be easy to write 2 plus 2 sine theta minus cosine squared theta. Why cosine squared theta? Because we had negative 1 times cosine squared theta up above in that last step. Okay? And then all over, well, we know what this is going to be because it's the whole reason why we did it, cosine squared theta. Okay, fantastic. Moving along. Actually, let's put a pause here for a second and revisit what we're trying to do. The left side of the equation, as you can see up top, is all in sines. And we have some cosines. So let's take a second to get rid of those cosines. How are we going to do that? Let's pop over to our trig identity sheet. And the one that comes to mind is this one. Okay, sine squared theta plus cosine squared theta equals 1. Well, what we can do is we can rewrite that as cosine squared theta equal to 1 minus sine squared theta. All we did was we took that sine and moved it to that side of the equal sign, right? So cosine squared theta equals 1 minus sine squared theta. Okay, great. So let's go back here and we'll make that substitution. So we're working all in terms of sines, just like the left side. Okay, so equals 2 plus 2 sine theta minus, this is where we make the substitution, 1 minus sine squared theta. And that's all over. Going to make the substitution again, 1 minus sine squared theta. Okay, fantastic. The next step is we're going to distribute this minus sign, negative sign, to the 1 and to the negative sine squared theta. You might not need a whole step for this, but I like to do it. Teachers like to see, how you're forming your thoughts. You're certainly not going to get penalized marks for showing this step. Okay. 1 minus sine squared theta. Perfect. Okay, so all we did was we changed the signs of what was in this bracket up top based on the negative sign here. Okay. So the next thing we can do is we can collect like terms. We have a 2 and a negative 1. Okay, fantastic. Let's do that. 2 minus 1 is 1 plus 2 sine theta plus sine squared theta. And that's all over 1 minus sine squared theta. Okay, now this is interesting. You can't really proceed without factoring. Okay, so I'm going to take a pause for a second here and just show you this 1. Just look at the numerator. 1 plus 2 sine theta plus sine squared theta. That's the same as if you were looking at 1 plus 2x plus x squared. All right, just treat sine theta as x, and we factor this. That's going to be the next step. Okay, so let's get rid of this. We'll rewrite it, but we'll rewrite it factored. Now, if you're not quite sure how the factoring works, check out one of my videos on factoring, but essentially that's all we're doing here. And when we factor the numerator, it's going to result in 1 plus sine theta multiplied by 1 plus sine theta. The denominator we also have to factor. Note that the denominator is a difference of squares. Again, if you're not sure what a difference of squares is, diff of squares, it's when you have one square root, 1, minus another square root, sine squared theta. So when we factor a difference of squares, it just simply looks like this. 1 minus sine theta multiplied by 1 plus sine theta. Okay, well, this is convenient. We can cross things out now. What can we cross out? Well, I see a 1 plus sine theta up top, and I see a 1 plus sine theta on the bottom. Now, unfortunately, these other two brackets can't cancel out. That's fine. So what do we have left? We have 1 plus sine theta over 1 minus sine theta. Now let's have a quick look at the top just to see where we are in regards to the question. Whoa, we did a lot of work. 1 plus sine theta over 1 minus sine theta. Hey, look at our left side. 1 plus sine theta over 1 minus sine theta. All we do is draw a line all the way down to the bottom. And some teachers like it when you go left side equals right side. Okay, that is how you prove this trig proof with the help of some trig identities as identified over here. Pause the video if you want to see these trig identities. They're kind of the ones you need. And like I said, really hope that your teacher provides these for you. Otherwise, it makes these questions very difficult. Thanks for watching, and I'll talk to you soon.